Hi students, welcome to physics classes. Last class we discussed about gravitation part 1. Gravitation part 1 we have discussed about gravitational force, and after that we discussed about acceleration due to gravity. Now we discussed gravitational force is an attracting force. It is between any two objects in the universe, and we derived gravitational force formula also by using universal law of gravitation. Force F equal to G m1 m2 by r square. m1 m2 are the masses, r square is the distance between them. If one of the object is earth, then m1 becomes capital M, m2 becomes small m. Then force of gravity is G capital M small m by radius of the earth square, r square we discussed. After that we have discussed about acceleration due to gravity formula we have discussed, and we can say this is relation between capital G and small g also. G equal to G capital M by r square. And here from this formula we found G value on earth is nearly equal to 9.8 meter per second square, and G value on moon 1.7 meter per second square. If you take the ratio, G value on moon is equal to G value on earth divided by 6 times. And now we can say this G value depends on mass of the planet and the radius of the planet, and it is not depend on mass of the object. Remember, it is not depend on mass of object. If you drop a bigger object and small object, both will fall at same time. So here G value is depends on mass of the planet and the radius of the planet. It is not depend on mass of the object. This value of G derived by taking Earth is a perfect sphere, but actually Earth is not a perfect sphere. Equator radius is more than pole radius. Equator radius 21 kilometers more than pole radius. So G value changes as radius of the earth changes, G value also changes. So at different places on the earth surface, G value will be different. Now we will consider near the poles and near the equator. Variation in the value of G with the shape of earth. Just now we discussed equator radius is 21 kilometers more than pole radius. G value near the equator we can write G equator is equal to capital G M by radius of equator square. G value near the poles we can write Gm by radius at poles square. So if you take the ratio for equation 1 and 2, we will get Gp by Ge, acceleration due to gravity near the poles divided by acceleration due to gravity near the equator, is equal to Gm by Rp square divided by Gm by Re square. Gm gets cancelled, then 1 by Rp square by 1 by Re square. So it becomes Re square by Rp square. As we know, radius near the equator is more than radius near the poles. We can say G value at poles is more than G value near equator. Acceleration due to gravity near the pole is more than acceleration due to gravity near equator. Next, variation in the value of G with the altitude or height above the surface of earth. Now we have seen G value on the surface of earth Gm by r square. G value on the surface of earth. For example, we will take A. At point A, G value Gm by r square. If the same object is taken to h height above the surface of earth, near the surface of earth we will take distance between two objects is r. as it is taken to particular height, distance between two objects is increased, no? So g value at a height h equal to gm by, instead of r we can write r plus h whole square. It can be taken as equation 1, it can be taken as equation 2. Then if you take the ratio equation 2 divided by equation 1, we will get gh by g equal to, gm gets cancelled, 1 by r plus h whole square divided by 1 by r square. Then it can be r square divided by r plus h whole square. So g value at a height h equal to g into r by r plus h whole square. As we know, r plus h is greater than r, then g value at a height is less than g value on the surface of earth. So this indicates that as we are going away from the surface of earth, g value decreases. Next, variation in the value of g with depth below the surface of earth. Now we have taken g value on the surface of earth, g equal to gm by r square. Now here, when the object is taken above the surface of earth, we derived formula by taking mass of the earth is constant, mass of the earth not changed. But when we go inside of the earth, depth d from the surface of the earth, mass of the earth changes. If an object is coming up to here, this much mass only we should consider. So mass of the earth is not constant, mass is changes. So whenever mass is changes, we should not take mass as a constant. When we take on the surface of earth, total mass is considered. When we take inside the earth, total mass is not considered, no? So we can't cancel this. Here, instead of mass of earth, we will take density of the earth. Density means unit volume we will consider. So it won't be changes, it will be constant. Now what is the formula for density? Density rho equal to mass by volume. From this we can write mass of the earth equal to density into volume of the earth. That is equal to density into volume of the earth. Earth is considered as a sphere. What is the formula for volume? 4/3 pi r cube. So g value on the surface of earth can be replaced with g equal to g density 4/3 pi r cube divided by r square. R square in r cube, r time cancel, then it becomes g rho 4/3 pi r, g on the surface of earth. Now if you take an object to depth d below the surface of earth, distance between them becomes r minus d. Then gd equal to g rho 4/3 pi r minus d. Directly we can write. When it is on the surface of earth, r. When it is taken at a depth d below the surface of earth, r minus d. So if you take the ratio gd divided by g equal to g rho 4/3 pi r minus d divided by g rho 4/3 pi r. This all gets cancelled. Then remaining is r minus d divided by r. Then we can write this r is dividing both r and minus d. So 1 minus d by r. From this, g value at a depth d equal to, if this g is going that side, g into 1 minus d by r. Now by using this formula, if an object is taken to center of the earth, if an object is taken to center of the earth, then d becomes r, and both gets cancelled. 1 minus 1 equal to 0, 0 into g, 0. So g value at the center of the earth is 0. At center of the earth, G value is 0. This is the second part in the lesson gravitation. Now if possible, I'll make some numericals and I'll discuss in the next part. Thank you for watching. Please subscribe and share it to your friends. Thank you.